Okay, let's take a look at how we connect ammeters and voltmeters in circuits. So not so long ago we discussed the idea that it's a voltage that causes current. Because we have a different electrical potential on each side of a device, that causes the current to flow through the device. And so voltage is always across a device, and a current is always through a device. And whenever I hear students say current across or voltage through, I know they're not quite getting it. Symbol for voltmeter and ammeter are simply a circle with a V or an A in them. And the voltmeters, they're measuring voltage across. So what you do, they're very easy to connect. You just connect one probe on each side of your device. So you connect across the device to measure voltage across. Now if you want to measure current through a circuit, then you got to break open the circuit and force the current to flow through the ammeter. Now, if we're going to have good ammeters and voltmeters, they can't change what they're trying to measure. Let's say I've got a circuit here with a resistor in it, same resistor here, same battery, same battery. If I want to measure the voltage across the resistor, I simply take my voltmeter and I put it here. Now, that voltmeter is not supposed to affect the current. So there isn't supposed to be any current that goes through the voltmeter. You want this I equal to 0 because you don't want to drain any current away from the circuit that you're measuring. Now, if no current is to flow through the voltmeter, the resistance of the voltmeter should be infinity. So ideal voltmeters have infinite resistance so that they don't drain any current away from the circuit. Now, for an ammeter, what you have to do is break open the circuit. So you've got to break open some wires. Let's say we break open some wires here. So we break open our circuit and then we force the current to go through the ammeter. Now, we want the ammeter to have 0 resistance because we want that current to flow through it easily without any interference whatsoever. So an ideal ammeter should have 0 resistance. Ideal ammeters have 0 resistance so that they do not impede the current in the circuit. Okay, a quick IB question. Pause the video, read it over, and try this question now. And hopefully what you said was that the voltmeter is going to be infinite resistance. The ammeter's got to be 0 resistance, so the one that's correct for both would be answer C here. Here's an IB multiple choice question. Pause the video, try the question, come back for the answer. Key thing to realize here is the ammeter has 0 resistance, whereas the voltmeter has infinite resistance. So this ammeter is going to be like a short circuit, effectively taking this 6 ohm resistor out of the circuit because all the current would go through the ammeter. The problem is no current's actually going to flow because we have infinite resistance here, because this is just a series circuit, a 6 ohm followed by an infinity ohm in series. So our ammeter reading will be 0. The voltmeter reading, well, we've got a potential divider here. And out of that 6 volts, the fraction that goes across the voltmeter depends on the resistance of the voltmeter. And since it's infinitely times as large as 6 ohms, all of the 6 volts will be across the voltmeter. So the correct answer here is B. Usually in class when we do experiments we use these digital multimeters. I just want to go through the steps that you have to go through in order to use one of these. First thing, you've got to decide what you're measuring. So if you're measuring voltage, and we're usually measuring DC volts, which would be the straight lines here. So this is where we'd move this knob if we wanted to measure DC volts. And we'd move our knob over here if we wanted to measure DC amperes. These wavy lines are for AC signals. AC signals are when the current sloshes back and forth and changes directions about 60 times per second. Next thing you've got to do, so we've done one, we switched our knob. Secondly, the red probe, this one right here, it needs to go in the proper socket here. So it's hard to see on this one, but I believe that there's some letters underneath this. One of them would tell you that it's a voltage that could be read with this, and I believe resistance would be in this socket as well. If you want to measure current, then you'd have to move it to this other socket. So second step, choose the correct socket. Next thing, you've got to know approximately how big of a voltage or current you're going to measure. I was expecting the voltages to be around, say, 12 volts. Then I'd go here to my 20 volt scale, because 12 is above, this is really 2 volt. 12 volts would be above 2 and under 20, so 20 would be the scale that I'd want to use. And then your last step is to connect the probes. Now remember, if it's a voltage, you got to place it across the device. That means you don't have to do much work. You just put one probe on one side, one probe on the other side. If it's current, you've got to do a little more work, because you've got to break open the circuit, and you can either do that just before the device or right after the device, and then make the current go through the ammeter and out again before it goes into the device that you're trying to measure the current through. And that's all for today, folks. Thank you very much.